Over the highly sensitive borders of Kaliningrad, Russia's exclave surrounded by NATO member states, airborne intercepts are a daily reality. These airspace mortars routinely host tense encounters between Russian aviators and Western forces. The NATO patrols in this region fly highly advanced modern combat platforms. Jets like the French Rafale serve as a benchmark for contemporary aerodynamic and electronic warfare capabilities. Russia relies on the Su-30SM2 to counter these patrols, a heavy fighter evolved directly from a Cold War classic. When Russia's own fifth-generation stealth program, the Su-57, ran into severe delays, the military had to pivot. They needed capable jets immediately, forcing a shift toward a doctrine of evolutionary modernization. They looked back to the Soviet Union's most capable air superiority fighter, the Su-27. In its time, that baseline airframe possessed world-leading internal fuel capacity and exceptional aerodynamic agility. The critical stepping stone happened in the early 2000s. With heavy financial backing from India, the Su-27 was modified into the Su-30MKI for the Indian Air Force. This export variant proved that the older, twin-seat airframe could successfully carry massive, heavy modern upgrades without losing its edge. This historical lineage left Russian engineers with an aerodynamically proven, extremely long-range blank canvas. All they had to do was fill it with 21st-century internals. The foundation of the SM2 upgrade is a complete overhaul of its propulsion. Engineers ripped out the older engines and dropped in the AL-41F1S, the exact same power plant used by Russia's premier Su-35 air superiority fighter. This chart details the raw quantitative performance gains. The new engine provides approximately 16% more thrust than the older variants, while simultaneously requiring less maintenance, burning fuel more efficiently, and boasting a substantially longer service life. In the air, that 16% increase translates to a completely different class of kinematic performance. The aircraft accelerates faster, sustains high-speed turns longer, and achieves a higher climb rate, especially at high altitudes, where thinner air usually starves engines of power. When you combine that thrust with vectoring nozzles, mechanisms that physically steer the aircraft by shifting the exhaust direction, the Su-30SM2 achieves extreme post-stall maneuverability. This makes it incredibly agile in close-range engagements and highly capable of dodging incoming missiles at all ranges. Beyond raw speed, the AL-41F1S produces the massive electrical surplus required for the jet's next phase of upgrades. Its high-efficiency rotation generates the power necessary to run the aircraft's advanced sensor suite. That surplus electrical power is fed directly into a drastically heavier, significantly more powerful radar suite, entirely changing how the Su-30SM2 perceives the airspace around it. This interface shows the data. Top left, R-77 missiles are loaded to engage targets at extreme distances. On the right, the wide tracking volume deploys the R-77M, a next-generation beyond-visual-range missile, putting lethality on par with Western platforms carrying AIM-120D or Meteor missiles. But the jet's true reach comes from the integration of the R-37M heavyweight long-range missile. This weapon is built specifically for extreme standoff engagements, allowing the Russian jet to fire on adversaries from distances where return fire is aerodynamically impossible. Marrying the electrical power generation of the Su-35 with these specific high-end munitions shifts the Su-30SM2's primary role. It transitions from a traditional close-in dogfighter into a long-range, beyond-visual-range sniper. Modern aerial combat is an information processing problem. The massive influx of data coming from advanced radars, electronic warfare sensors, and long-range targeting computers creates a severe cognitive load for a single pilot flying a heavy fighter. This leads to the final pillar of the SM2 upgrade, the retention of the two-seat cockpit. While many forces use twin seats primarily for training, here it is a deliberate tactical choice designed for complex combat environments. It allows for a strict division of labor. The pilot in the front seat focuses entirely on exploiting the aircraft's extreme thrust vectoring and kinematic performance to keep the aircraft alive and in position. Behind them sits a dedicated weapons systems officer, acting as a battlefield manager. While the pilot flies, the officer sorts through the dense radar data, actively employs electronic warfare countermeasures, and guides those long-range R-77M missiles to their targets. This two-brain system ensures that these complex engine and missile upgrades are fully utilized, rather than becoming a distraction in the chaos of a long-range mission. Which brings us back to the hostile borders of Kaliningrad, where Russian aviators are actively testing this hardware against advanced NATO forces. When flying against nimble, highly capable Western interceptors like the Swedish Gripen, the Su-30SM2 relies on its distinct combination of advantages to outmuscle the competition. It takes the massive territorial range and heavy payload of a Cold War Su-27, propels it with the modern engines of an Su-35, arms it with sniper-like standoff weapons, and manages the entire battle space with a dedicated two-person crew. The Su-30SM2 proves that in modern military aviation, maintaining air superiority doesn't always require waiting decades for a clean-sheet stealth program to mature. Through targeted, meticulous upgrades, an aging design can be armed, powered, and adapted to maintain a distinct advantage over its rivals.